Okay, welcome back. Here I wanted to talk about radical equations. So when we're talking about radical equations, we are talking again about being able to solve for a variable. With a radical equation, the very first thing that you need to do is you need to isolate your radical and get it completely by itself. I kind of like to think of radicals like candy bars. If you think about most candy bars, when you go to the store and you buy, say, a Twix bar, before you can actually eat it, you have to unwrap the packaging. Of course, unless you're somebody who likes to eat packaging, well, then of course you would probably just bite right into it. But I personally like to, unwrap it to just eat the chocolate. However, to each their own, not judging. So radicals I like to think of in the exact same way. I like to think of them as like candy bars, and that you have to, in order to solve, you have to unwrap them and get to their center. And what I mean by that is you want the radical to be totally by itself. You don't want to have anything else on the outside of it. And in this one here, clearly we do. So before you even get to working with your radical, you have to move any outside piece to the other side of your equation. So here, this would leave behind my cubed root of 6x plus 9. And I would set it equal to 5 minus 8, which is a negative 3. Once you get the radical totally isolated and on its own, you have to then look at its index. So this index right here is going to tell you what you need to do with your next step. In that you have to raise by the appropriate power. What that means is this is an index of 3. So I have to take my radical and I need to cube it. Whatever I do on one side, I have to do to the other. When I cube a cubed root, that's going to leave behind 6x plus 9. Negative 3 cubed is going to give you a negative 27. Now all you have to do is solve for x. So we have negative 27 minus 9 is going to give you a negative 36. So my 6x equals negative 36. Divide everything by 6 and you get that x equals negative 6. Now, once you get down to an answer, you must check your solutions to see that the result you got actually is a true answer. So, to check says I have to plug in. So this is still the cubed root of, and this was 6 times a negative 6 plus 9, and then plus 8 equals 5. Well, this is going to be the cubed root of negative 36 plus 9 plus 8 equals 5. This is the cubed root of negative 27 plus 8 equals 5. The cubed root of negative 27 you'll find out is a negative 3 plus 8 equals 5. Negative 3 plus 8 gives you 5 equals 5. Thus we have a true solution of x equaling negative 6. Now in this one, notice I have a variable on either side. However, I still have a wrapper, so I have to move this before I can do anything else. So this is going to give me the square root of x plus 1 is equal to x minus 1. Now, again, I have to look at my index. And when I look at this index here, notice there isn't anything listed. If you don't see anything written, it is assumed that your index is a 2, meaning we assume that this is going to be the square root. That means I have to square both sides. When I do that, this becomes x plus 1. And then when I square this side, x and x is x squared. I have x times negative 1, so this will end up being a negative 2x when I'm all said and done, and then plus 1. Okay. Remember, you have to FOIL and combine. Okay. I then want to take this side of my equation and move it over. So 0 is equal to x squared. Negative 2x minus x is a negative 3x. 1 minus 1 is 0. Keep solving for x. I can pull an x out and leave behind x minus 3, which means I have two solutions. I have that x equals 0 and x minus 3 equals 0, so x equals 3. Now, in this case, I have two solutions that I have to check. So the first thing that I'm going to check is I'm going to check that x equals 0, and I want to know if this works. So I have the square root of 0 plus 1 plus 1 should equal 0, because anywhere you have an x, you have to plug in your value. 0 plus 1 gives me the square root of 1 plus 1 equals 0. Square root of 1 is 1 plus 1 should give me 0. And in this case, I have that 2 does not equal 0. Therefore, x cannot equal 0, because this would be called a false statement. Now I have to check the other one. So now I want to check whether x can equal 3. So I start with my square root again, and this becomes 3 plus 1 equals 3. 3 plus 1 is 4 plus 1 equals 3. The square root of 4 is 2 plus 1 equals 3. And here I have 3 equals 3. This is considered to be a true statement. Therefore, the only solution is x equals 3. Okay. So there you have it, the approach and the methods that are used in order to solve radical equations. Okay. If you have any questions, please let me know. And remember, math is bananas. So just keep smiling, be sure to ask tons of questions, have lots of fun, relax, and as always, I'll see you next time.